Good morning, everyone. My name's Calum Stewart, and I'm presenting today on behalf of SPEE3D, the Australian manufacturing company. But as you may tell from my tones, I'm not a real Australian. I'm in fact presenting today from Scotland, where I work for SPEE3D in their European program. SPEE3D being a Melbourne-based and a Melbourne and Darwin-based company. Last year, I was in fact an Australian soldier. So I was working with the Australian Army. And the story of the last year for SPEE3D being that I was very fortunate to receive funding, quite a lot of funding, a couple of $1 million or just short of, to run a trial for Australian Army into advanced manufacturing or additive manufacturing. And the Australian Army made a cracking decision in that they were willing to go all in from the very start. And so a large amount of funding to have a proper and serious look into whether distributed advanced manufacturing was of any worth to them. They knew that it was a thing, they knew there was capability out there, but they couldn't tell you truly whether it was of any real worth to them. And the other point of the trial was to demonstrate sovereign capability. So this was another important part. Could the Australian Army do this with Australian technology and Australian people? And in my search for a partner for the project, I was introduced to Byron Kennedy and Stephen Camilleri, who are the founders of SPEE3D. And the last 12 months are, as I say, a history. And we've had an amazing 12 months of bringing the Australian Army light years forward in the latest in cold spray manufacturing. I've got here now a video for you, which I'm going to share, and it will just tell the story of what we've been achieving over the last 12 months.
I'm Lieutenant Colonel Kane Wright, Commanding Officer of the 1st Combat Service Support Battalion. Over the last few months, the Australian Army have been conducting the world's first field trials of a warp speed 3D metal printer. Earlier this year, the Australian Army announced a $1.5 million investment into a 12-month pilot of SPEE3D technology. The program includes the training of soldiers in 3D printing and the trial of SPEE3D's large format warp speed 3D metal printer. The trial is designed to test the feasibility of deploying SPEE3D metal printers both on base and in the field. Warp speed uses patented cold spray technology that enables significantly faster and more cost-effective metal part production. Developed in Australia, the printer is capable of printing large metal parts up to 40 kilograms at 100 grams per minute. The trial has proven the printer and auxiliary container can be easily transported on the back of HX77 trucks. This 2-week training exercise at Mount Bundy is the second in a series of exercises in which we are putting the warp speed through rigorous field testing, for example, loading and unloading in various terrains, emergency stops and redeployments, and general operation in austere environments. Soldiers have been training at Charles Darwin University for over 6 months now, learning everything from design to certification of 3D printed parts. They have produced over 50 case studies of parts that can be replaced in the field with metal 3D printing. As an example, here is one of the parts produced today, a bulk fuel module mounting bracket which enables safe operation of manual fuel pumping. This part was designed by one of our trained soldiers and is able to be printed, heat treated, machined, tested and put to use here in the field. The ability to print repair parts in a deployed environment will significantly reduce our footprint and repair damaged equipment on the spot to get us back to our main priority.
Fantastic. Okay, so that video there gives you a flavour of what the SPEE3D and Australian Army trial was all about. Actually, in the first 6 months, using cold spray, we as an army were able to demonstrate that the technology exists to allow soldiers, and therefore, if you wanted seamen or airmen, military members, to take the latest manufacturing techniques out into the field and use it to make real worthwhile parts. And this is what defense forces around the world are looking for. And specifically, defense forces, having been there and been in that environment, we need a capability that is deployable. Now, the topic for this part of the conference is cold spray at the point of need. And I was asking myself, what is the point of need in Army? Where specifically is it? Now, there is no one location. Armies will always say they want to repair and maintain equipment as far forward as possible, to keep that piece of equipment in the hand of the user so the fight can go forward. The true is at sea, the same is true at sea as it is in the Air Force. And so some photos here to demonstrate the different environments in which we took our cold spray technology. So if you look at the top left, that's either day 1 or day 2 of the Australian Army having a cold spray technology in its workshop. And that is big industrial warehouse, lots of tradesmen from draftsmen, fitters, turners, electricians, vehicle mechanics, all working under that sort of environment on a day-to-day basis in their barracks. And if you are in Army, you would call this second line support. Okay, it's within the brigade environment. You wouldn't take this sort of technology any farther forward than this point because frankly, it's too big, bulky and not maneuverable. This is absolutely the limit of where you can take a manufacturing capability. And it's actually very testing to get it that far forward because whilst the top left there shows you a warehouse, second line support exists in the field as well. If you look at your photo on the right-hand side, you'll see this was within 2 weeks of having the printer in Darwin with my battalion, we took it out into the field. There you can see me with the big green arrow. That is obviously a Ferrari red or a SPEE3D red industrial printer. And we have pushed ourselves from the very start to see if it can survive the rigors of the field. And this exercise was specifically about, can the technology survive the simple things of field life? That being, can you pick it up, put it down, and we're talking on the back of trucks, set it up, get it running, calibrate it, repair it if needed, and use it. How noisy is it? How much light does it emit? How tactical can this sort of equipment be? Now, obviously, this is the version 1 taking it into the field, but valuable lessons. But that's a fairly benign environment looking at it. Bottom left was the second exercise that we took the cold spray technology on. If you look at that bottom left picture there, which is a great picture, you'll see the printer in the middle of a dust storm. On the far left of the photo, you'll see the generator and the dust extractor, again, easily moved on the back of the Australian Army's Rheinmetall trucks. And on the right-hand side, behind all the ponchos, is where the rest of the manufacturing unit was housed. So we're talking the soldiers with their CNC machines, with their test equipment, with their heat treatment, and with their computers so they can do drawings. So the point of need for Army, this is as far forward as you would get it. In modern day environment, what would that look like? We're talking Afghanistan, we're talking Camp Leatherneck, we're talking Camp Bastion. It would look something more akin to what you've got in the top left there, but in the theatre where the soldier needs the part. There is no point in Army's view or in the mind of Army Defence of having this sort of capability and having it in a different theatre or a different country from where the soldiers are, where the customer is. So if I was to move on now and demonstrate a couple of the parts that we've made in this trial using cold spray. Here we have one of the relatively new Australian Army fuel trucks, bulk fuel capability. It's a Rheinmetall stroke manned truck and an Australian fuel system on the rear. There are maybe half a dozen of these that would support one brigade, one fighting brigade, so let's say a few thousand soldiers. And they are battle-winning bits of equipment because without fuel, your army doesn't move. So if these break, these are the #1 priority for repair. And this is a brand new bit of kit. Now, with every bit of brand new kit, there are always points of failure, and that's to be expected. So there's no finger pointing here. But one of the parts on this vehicle that we knew consistently failed was this, a mounting bracket. Simple mounting bracket, nothing difficult to it. But that part allowed you to prime the pump, and it was shearing. It's actually made of two parts. It's a swivel. You can only see one part at the moment on the slide. But they don't exist in the supply chain. Now, if this was Afghanistan, do you say we need to fly this part from around the world into Afghanistan? Or worse still, do you go to your supplier and find out that it isn't in the supply chain and that you need to wait for the part, then to fly it out? Or do you say we have our own manufacturing capability, but it's in America or it's in the UK or it's in Australia, it's not in the theatre where we need it, and say to that manufacturing organization out of theatre, we need you to make a bulk fuel module bracket for us. Okay, where's it breaking? What's going on with it? Well, the customer's in Afghanistan. That's a pretty difficult conversation you're now having to have with a customer in Afghanistan, a design team in another country trying to make a bespoke solution for you. This is why defense forces understand that distributed manufacturing at the point of need is in theatre. It's not straight as far forward with the fighting troops. That's one step too far, but it is absolutely in theatre where the customer can engage with the manufacturing facility. So cold spray at the point of need. What does that look like for defense forces? It's certainly in theatre, and it's as far forward as you can get it, where the customer can meet the manufacturing facility. Now, just, it's nice to see there's a real metal part of real worth to the army, printed in 30 minutes. The soldiers that designed it, it took them a couple of days. This was one of their first parts. It took them a couple of days to come up with the drawing and design it and have confidence in their design. The print part was particularly easy. The testing part, SPEE3D, held the soldier's hand through that process to get them through a proper testing process. And at the end of it, you're asking the commander of that defense force, are you happy with this part being added to one of your vehicles? When the original part, when the real part is available from the supplier, we'll use that part. But until then, this is the manufactured solution. And it's a classic example of what's the cost of not having this part versus what's the cost of the part. We get asked continually, well, is it not cheaper just to go source it and fly it in? Yeah, but when do you need that part? And what's the cost of not having it in time? But these are all arguments which in our industry, we all understand. There's a part actually being fitted to the subcomponent of the vehicle. Next part, I'm going to move quickly because I realize we've only got 30 minutes for the whole segment, and Vic probably wants to chat. Gunner's ratchet, 300 armoured vehicles, M113s, buckets in Australia. 5 out of every 6 do not have this piece of crew equipment, simple gunner's ratchet. It's a very old vehicle, it's an old gun, and therefore it's no surprise that the tooling that goes with it over time breaks, disappears, gets lost. But they're crucial. You can't maintain the gun without this spanner. 6 months to get it made. We've had quotes in the Army of up to $1,000 for this part. SPEE3D had it as one of the case studies within the trial, and you can see the results there for yourself, just how quickly and how easily it was for us to provide capability using our technology. And again, where do you do it? You make sure you're doing it in theatre as far forward as is practicably possible. Final piece, the Australian Army have a particularly old fleet of landing craft. So we're talking beach landing crafts vessels. And no surprise that when it comes to pump housings, particularly I think if the original is made of aluminium, it's going to corrode, it's going to fail, it's going to break. And we are talking Vietnam era technology or Vietnam era vessels. And these fail regularly. And it was one of the more complicated pieces that the soldiers had to redesign and print. But again, where would you be doing it? You would be doing it in theatre as far forward as possible. So what's next for cold spray as we see it here in SPEE3D? We are having fantastic success with the Australian Army. We're going gangbusters. And we are in discussions with other defence forces around the world and defence primes. And the conversation is always about use cases. Am I going to be able to make use of this capability, of this technology? This example here, Titan, is the British Army bridge layer. Tanks can't go anywhere if they cannot cross large gaps. Tanks are useless at crossing large gaps, so you need a bridge. And it's, as you can see there, Titan carries a bridge on its shoulders and drops it over the gap. Titan came into service in 2006 and it has 1,400 components that are no longer available in the supply chain. This is where cold spray gets into its defense market. I've went back and I've watched some of the presentations from the previous workshops, in particular, Dr. Champagne's presentations at the start of each year. I see his timeline of what's happening with cold spray and what he expected to happen over 10, 15 years. And the final stage being near net parts. We are absolutely at this point with cold spray. So long as you can deploy it, so long as you can get it into the theatre of use, you have a market for cold spray because the parts that are being made are to the standard required. And that standard I always coin in defense is good enough. The standard is it good enough for the job? I'm going to wrap up quickly because that's me been going on for 18 minutes. Point of need as far forward as possible in the theatre so the customer can engage with the manufacturing facility. Your technology needs to be soldier proof. It's soldiers, seamen and airmen that are going to be using it. And therefore it's got to be modern, it's got to be engaging, and it's got to be robust. When engaging with defence forces, provide a bluff bottom line up front. This is rapid manufacturing. It is not 3D printing. Down the bottom there, this is something, as the customer in Army, I got frustrated with immediately. Is this 3D printing or is it not? 3D printing, in my mind, I thought it was Star Trek stuff, replicator stuff. We all know that's not the case. It's rapid manufacturing. It's part of a process that defence forces want to be able to provide sovereign capability to manufacture. This is a great addition, but it is not a Star Trek replicator. Tell your customers this in advance. And the second to last one there, the quality standard for defence will always be good enough. It does not need to be to that of the original. It needs to be good enough for them to use it in the mission over a period of time that is defined by the commanding officer or commander who holds the risk. The supply chain will always hold primacy. Cold spray finds its niche in supporting and adding rigor to that supply chain. So if you have a 6-week gap for a bulk fuel module mounting bracket, and you can provide one for those 6 weeks, and it's only going out in 3 missions, and the risk is low, that is good enough. And that is the standard that cold spray needs to aspire to. That's me bang on 20 minutes. Thank you, Cold Spray Action Team, for the opportunity to speak. Hopefully after this, you'll see me online and we can have some discussion and some questions. Yeah, thank you very much. It was a pleasure to be here.